Hi, Assalamualaikum. Good morning, and welcome to my channel for simulation. Today we're going to look into how can we model pipeline pressurization. So we have heard many about pipeline depressurization. Now today we will look at how can we make a pipeline pressurization by using HYSYS. Okay, let's get into it. So let's take some gas pipeline and we will start the working. So once we go into it, I will tell you the whole details. So let's consider the window scenario. My pipeline is at around 20 degrees C, and the pressure of the pipeline. I will tell you the whole things. Let's consider this at 90 bar. For the composition, we just write some composition to it. And we will normalize it. So for the pipeline visualization, first you have to go to this blow down and simulation, press the drop down menu, and click on blow down. After this blow down, you have to the top down menu and click on pipeline visualization. It will give you some little bit info how can we do it. So once you open it, you can see the typical screen is there. I'm going to show you how. So it will say feed, body face, pressure drop piping, and a pipeline boundary. So this is a pipeline boundary that we need to pressurize, and this is a feed. So consider we have installed a new pipeline for some 20-kilometer pipeline. So from the feed we have taken it is on 90 bar pressure, okay, bar gauge pressure, and we have to fill this pipeline with 90 bar. So here, so mostly what happens during the commissioning activities, after commissioning activities, the EPC contractor or the construction contractor fill the pipeline with nitrogen for about 3 to 5 bar pressure, and then what happens? The pipeline is pressurization from a bypass of the main. You can say isolation valve. It can be isolation valve. It can be some kind of ESTP. It can be some kind of hand operated valve. And you have to in the design you have to provide some bypass to it. Some 6 inch, 8 inch, 10 inch bypass. And based on this bypass size will be based on the pipeline depressurization, pipeline pressurization, which I will going to talk in detail about. So in the feed you have to specify the pressure and the temperature and the ambient conditions and all that things, and which pressure is coming and what have to be done to the other side of it. So this is the basic model that are available, and I will show you how it's moved forward. So in the system, first you have to specify the air temperature. For my case, if I'm considering some winter or something like that, so I will consider the 5. I'm considering a moderate speed of wind at 1.5. So initial temperature of the pipeline I'm taking at 20, and it's around I'm taking it around 90 bar. Okay, inventory. So as I told you for the feed I will link it to the stream number this one, and I have linked it to the stream. For the boundary pipe, as I told you, boundary pipe is something else, and we only have nitrogen in it. Mostly the contractor for nitrogen in it. So what I do, I have specified nitrogen here. So this pipeline is filled with nitrogens. So when you go to the pipe we have to specify what the pipe is. So let us start. We can say that the bypass line, which needs to be pressurizing, the whole pipeline is around 4 is around a diameter of, take it at 80 schedule, and we take it around, you can say 6 inch, is correspond to 150 mm. And our actual pipeline is, you can say that uh, it's around something like 20 mm pipeline, 20 inch pipeline, because the pipelines are usually big. So I'm not putting any wall thickness, you can just put 19.05 artificial wall thickness. So this before to happen, you place an arrow or a glow pad. So the distance from the glow pad to the pipeline is very minimum. So I'm taking around only you can say 2 meters. And for the boundary pipeline, I'm taking the whole kilometer that I told you is 20 kilometer pipeline in our case. So no elevation is changing here, and let's go with no elevation is changing here. So then we will initially we can specify the boundary pipeline as I told you, so it's filled with nitrogen, so there is no liquid. So now come to feed. In feed we have to specify what the temperature, as I told you, the temperature will be around 20 degrees C, initial pressure will be around 990 bar. Feed diameter is again the same thing that we specified, that is 6 inch. Mass flow rate. This is the mass flow rate that we have to iterate. We will iterate this mass of molar flow rate and see how much time is taking and what the impact of the temperature. So there are mostly three things very important that we have to see in the pipeline pressurization. Number one is how many hours is taking to fill the pipeline. Second thing, and what's your design pressure of the pipeline. In my case, it is 0 degree design temperature. So we have to see that during the whole course of pressurization, the temperature does not go beyond 0 degrees C. So we will keep some margin of 2 to 3 degrees C in it. And number three is because of that pipeline spool that I'm talking about, the bypass. So there will be 90 and there will be 0 and the value open. There is a certain gradient of the pressure. So we have to check the velocities, what velocities we are getting here, so that the piping team can provide the adequate support to it. So these are the three things. Let's start it with some kind of, you can say, 5 to 8 mm safety. Or we can start with 35 mm. In RO, we have to specify that we don't want to go beyond 6 inch. So all the parameters have been made, so input is complete. Mapping is also done. In run control, we have to provide the time. This is also a time and error method. So just for the start purpose, I'm taking mostly the shift is around 8 hours or 12 hours. So I'm starting with, you can say something, let's say 12 hours. Since the initial 10 to 15 seconds or 60 seconds are very important, that's why what we will do, we add some strings to it, because initial times are very important. So 0 to 1 second, we are step sizes, we are reducing the step size to get the better of it. So for the initial, you can say, for the initial 1 hour, you have seen that I have put some very small stop size to get a better result. So once all things are complete, you can see we can send this. We will go to the result summary and run the program. So I guess we have put some bigger flow rate. Go back and update the flow rate. Oh, sorry, my bad. What I have done wrong, I will tell you. Yes, here the initial pressure we should have put 3 bar G. So I will tell you in detail about the plot or the major findings. These are the very important things to we have. Let's start that. So guys, so the results are being analyzed by the HYSYS. So you can see that now, whatever the time frame we have given, it is 12 hours, and the flow rate, you can see that we only reach up to 600 something pressure. So what we have to do, we have two things: either to increase the time more, about 24 hours, 18 hours, to get the pressure up to 90 bar G, that is around 1300 psi, or we have to increase the flow rate. So there's a trial and error method in this pipeline pressurization to achieve the things. And when we are doing this, we have to make sure that what are the impact on the pipeline and on all the things. As you can see that when I put the things, you can see the minimum wall temperature is now going to minus 1.537 degrees C. As I told you, for my case, in my case, my design temperature of the pipeline or the inner wall temperature is 0 degrees C. So we have to maintain around this minimum wall temperature around 1 degree C, 2 degrees. That's very important. And second thing, we have to also see what the input we have given in terms of the ambient things. So what we have done a very most case in a sense that our feed is also coming at 20 degrees C, ambient is also at 20 degrees C. So if we start anything from 20 degrees C, it will be very easy to that it will go beyond 0 degrees C. So here what we have to do, we took the we have to see the scenario where how we have to do it. So either we took it at 0 degrees C at the gas temperature, we took at 0, but we don't do the ambient as the same. So but so what we're gonna do, guys, since we got some of the result and another result after that, we will give some message that how many times it take and all the things. And what we will and we will can see the details of each and everything. If you put your details and put your cursor on all phase, it will tell you about the all phase. If you talk about the boundary pipe, it will tell you about the boundary pipe. If you click on this, and then it will tell you about the pressure drop pipe. Mostly the pressure drop piping is of low carbon temperature, so it can go beyond minus 37, 145 or something like that. Do you see? What we're gonna do, we're gonna specify the 20 here also. Increase some feed flow rate. So what I'm doing that I have changed the ambient temperature from 5 degrees C to 20 degrees C, and I've increased the flow rate also from 15 mmSCFD to 20 mmSCFD, and I will run the blow down analysis again. So the guys, the pipeline pressurization is running, and we'll see that, and this will once they finish. So the flow down calculation has been successfully completed. But the same thing, the thing is that we didn't able to reach that 90 parts pressure. So either we have to increase the time and the flow rate, and just we show the plots. So guys, you can see that the blue line is our boundary pipe pressure that has to be pressurized to 90 bar G, and our pink line is the upstream pressure. So we can see that after 12 hours, the pressure has now reached very near to the 90 bar, is around 80 bar something. So we have to increase a little bit time to 14 hours to get the results. So this is the pressure profile of it, and now let's see the orifice. So in the orifice, we come to know that for this orifice, the maximum size that we are getting in this 24 to 12 RG is around 28.5 mm. So we can say that there is no need to put 6 inches of hole, so it can be done into 1 and 2 line also. Let's go towards the wall temperatures. Because the thing is that one more thing about the orifice, since the orifice size will start to increase, when the delta P between the upstream and downstream is very low. So the lower the delta P, the higher will be the orifice. So we cannot just focus on this. We have to go until 90 body to see what the orifice size coming. We will done one more case for it also orifice. So for the wall temperatures, we can see that we have the pipeline, the pressure pipe and the boundary pipe, and we will see how the temperatures are there. So you can see that the pressure drop in the let me just uh, if you just click on the boundary pipes, you can see a better view of it. For pressure drop pipe, we can go to minus 45 for low carbon temperatures. So you can, so it will be, you can see that this black line is around something, you can say around 10, and it's way above the 0 degree C. You can see it. So this is the black line. The blue line is for the pressure drop piping, and yes, you can see the minimum this we are going is around 9 or 8 degrees, and that's very good for our case. So in media funding, we come to know that the maximum minimum wall temperature we are going around 8.4, and in the pressure drop pipe we are going minus 35 minimum liquid temperatures, because maybe due to the gas composition which I put, maybe there is some liquid is forming at the temperature. So for if results, so what we do just a quick one case in which we increase this time from 12 hours to 15 hours to see what the impact of it uh, on the oil size. And let's start this 15 hours and let's see what the results are like. So our blow down equation has been started. So since our time is approaching towards the 15 hours, so we can see that here this inflow pascal, so it's around 87 bar G pressure. So balloon calculation successfully completed. So you can say that in around 50 something seconds, 50,000 something seconds, we get the results, and now we'll see how the results are going. Hi, so guys, let's look into the results. So for the oil phase, you can see now, since after some time, since you know like when the pressure drop is minimum the CV that become the maximum. So what's the same thing happened here? So when you approach very near to that 90 bar G, you can see the maximum size that we required is around 100 something mm. So 100 mm corresponds to around 4 inch, 4 inch something. So 79, and so just this is 66, 79. And the last is around, so you can say it's something between 100 and something like that. I think can we zoom it also? Yeah. When we zoom in, we come to know that this 100 is there. So it's means that or we can do that. So we can manually calculate the pressure of the control also. So we have to first calculate then see the pressure P1 P2, and then using a simple CV formula we can get the CV, and we can go and check the manual flow catalog to see where that CV goes, and mostly it will be around 4 to 6 inches. So that's the thing for the pipeline pressurization, and you can see that we have put around 15 hours, but it's completed way before it. So it says that the pipeline pressurization runs ends at 5083 seconds. So if you go and check that, what it will do, it will be 50838.8 seconds. So it's around 14 hours. So guys, it says that it's completed in 14.12 hours, and the hours are changed from 23 to 1.06 mm, so it's around 4 inch. And so from this we can say that the important thing is the 4 inch blow pipe. 4 inch blow pipe we need to have. So I will make a new next video of it, in which I will tell you the details on how can we use these tabs to show the results. So just giving a quick overview of it. If you go to the view details, you can see that at every second how much the pressure is and how much the temperatures and all the things you can see from it. And the one thing that I was mentioning earlier, that is that we have to see the velocity we are getting at the pipe. So for the velocity pipe, I will show you. So as I was talking about with you, that the velocity point, so for the pressure drop we can go, and pressure drop, that's a very good thing is that we have to see the what the velocity are. We can set the velocity from there also. So as you see that every time in the pressure dog is the length we specify that was around 1.5 meters, and each interval of it is showing that how much is the speed. This is only showing at each second, and if you click on this each second, then it will open one more tab for each time second across the length of the pipe that we have specified 2 meters to see how the things are there. So you can see the velocities starting with around 100 meters per second, and until last it will be around 8, 9, or the normal velocities during your steady state what you get. So this is pipeline pressurization. I hope you like that video, and in the second video we will go into one more detail and we'll solve a real life example to get a better of it. Thank you. And in the comments, kindly tell me about the your questions and all, and on what other things do you need from me so that we can make a video of it and provide you that information. Thank you.